Hi, I'm Colin Walls and I'm here once again to talk about embedded software. Today I want to look at what we can learn from experience, specifically experience of debugging code. Engineers spend a certain amount of time developing code, writing stuff, designing and then writing, but they spend a lot of time debugging. Now how can we make that better? Well, it's very easy for people who've been doing something a long time with a lot of experience to say, well, back in the day we did it in a particular way and that was better. Well, maybe. Often, back in the day was very different to the present day, and therefore their experience is not directly relevant to what we want to do now. However, I do think we can learn from experience and adapt it sometimes. So let's think about debugging code. If I go back to my first experiences of writing software, the way we went about it was pretty primitive by modern standards. Access to computers was a lot more difficult. So we would write the code literally with a pencil on paper. We would write it very carefully, try to get the syntax right so that the compiler wouldn't reject it. And having written it to our satisfaction, we would then spend time working through it on paper to figure out if the logic was right, doing our best to debug it at that initial stage. Only when we got to the point that we felt we really had got it right would we send it to the computer and try and execute it. Of course, you commonly have problems. There'll be syntax errors and you have to go back and fix those. We're only human, errors get made. And then there will be bugs in the code, errors in the code in terms of its execution. Our approach to fixing that tended to be put in some extra print statements and have a look what's going on. Well, that was fine. That was then, this is now. What about embedded software development? Does this approach work? Well, start off with the debugging bit, putting in extra printfs to do debugging. Plenty of people think that's a good way of debugging, but there are quite a few downsides of using printf as a debugging tool. First off, it takes up memory. The printf function can be quite large, and embedded systems often have limited amounts of memory. So using an output function of some kind might make sense, but probably not printf. Next question is, where does the output go to? Well, if your device has a screen or an output channel or something, well, you can do something. You can send it on across a network, I don't know. But where does printf output go to? It's not obvious if you're not dealing with a conventional computer. Next thing, what about if you've got a multi-threaded application? Multiple tasks are all doing printing. What happens to all that output? Does it all get mixed up? Well, maybe. You need something to sort all of that out. And that's not a problem we used to have years ago, but we would now. Additionally, if you want to change the variables you're looking at, change your view from a debugging perspective, you have to rebuild the entire application with printfs in different places. And lastly, printing takes time, the formatting takes time, so therefore the printf statements will mess up any real-time application. And that will introduce bugs of its own right. So you may introduce bugs by trying to debug the code. So that's not really a very good approach. A better approach is to use proper debugging tools, and most debugging tools connect to the target using JTAG or something very similar to that. This has a number of facets. One is there is no additional code on the target. That's excellent. It means you're not using up additional memory. You may have a little additional code on the target for certain purposes, but in general you can do some debugging with none at all. Displaying the data is no problem because you can see it on the computer you're using for development, which is connected to your target device using the JTAG connection. Debuggers tend to be task aware. This sometimes involves putting a little extra code on the target, but basically it means the debugger can sort out debug information from multiple tasks and present it to you in that form. You only have to rebuild your code when you find a bug and you want to fix it. Every time you want to change your debug view, you simply tell the debugger what else you want to look at. You don't have to change your code to change your debugging. And it's also true to say that JTAG is only marginally intrusive. It can have effect on real time, but it's quite minimal compared with executing large amounts of code on the target. So the printf approach is probably not the best way of debugging. JTAG offers a lot of improvements and is certainly the standard way that many embedded developers work. Backtrack to the way I used to program years ago, pencil and paper. Maybe we should do that though. because one of the big advantages was when we actually gave our code to the computer, it tended to compile fairly quickly. We didn't have lots of compile cycles because we didn't make that many mistakes because we went through it very carefully. Same with the debugging phase. Because we worked through it on paper, typically we eliminated some of the more obvious bugs long before we threw technology at it to solve those problems. So maybe we can learn from history. That's all for today. I'll be back again soon with another embedded software video, and I look forward to seeing you then. Bye for now.